Okay, so you should have, by now, you should have filled in column number 5, which is the light bulb temperature using the chart. The temperature in Kelvin for each of your different R divided by R sub 0 values. So now you should have column number 5 filled in. So now you could fill in the 7th column, which says calculated light bulb wavelength. And so in order to do this, you're going to use Wien's law. So Wien's law says that the lambda maximum is equal to 0.0029 divided by the temperature. So take 0.0029 and then divide by the temperature that you got from column number 5. And then put that in column number 7. Okay, and I want you to look at those calculated wavelengths, and then up in the concept introduction there is a color chart that has the different wavelengths of light on it, and then what are the wavelengths in meters. So go up to that and look and see where those wavelengths correspond. So are they in the visible part of the spectrum? Are they in the ultraviolet part? Or are they in the infrared part of the spectrum? And just record that. Then for the observed light bulb color, let's just leave that one blank. So the very last column, we're going to leave it blank. Okay, so now we've got the chart pretty much done. So what's the point? So now that we've got this chart, what are we going to do with it? Well, we're going to graph it. So what we're going to graph is the measured light bulb brightness F column versus the light bulb temperature. So the light bulb temperature is going to be sideways on the graph, and then the brightness F is going to be up and down. So what I want you to do is to highlight both columns. Now you cannot have any letters in there. It can only have numbers. So if you, for some reason, you put in the temperature of 2000 K, erase the K. So in those two yellow columns, you can only have numbers. Otherwise, it can't graph it. So you're going to highlight both of those columns, the temperature column and then the light bulb brightness F column. All right, now you should know how to graph. If you don't know how to graph, then you're going to need to go to the document under the classroom materials that says how to graph using Microsoft Excel. So I'm not going to go over that with you because you should already know how to do that. But remember, you're going to go to Insert, and then you're going to click on the Scatter one, and then it's going to graph it for you. And then once you graph it, then you click on a data point, and then you click on where it says Add the Trend Line. Okay, and then you're going to have a some kind of a graph. You need to decide what kind of a graph it is. Is it a straight line graph? Is it a exponential graph? Is it a power graph? So you're gonna run through those various kinds of graphs until you find the one that matches the data that we have. Okay, hint, it's a power. Yeah. So it is a power graph. I know it might look like something else, but trust me, it's a power graph. Okay, then you're going to, underneath that, you remember where you click on display equation on the chart? So that what you're going to get is y equals some number x to some power. So that's what you're going to get when you display the equation on the chart. Now, I don't care about the number that comes in front of the x. But what's really important is it's x to some power. That's the whole goal of the experiment. Round that number either up or down to the nearest whole number and see what you come up with. Okay? Now, the y is the up and down part of your graph. But what was the y? What were you really graphing up and down? That was the brightness. That was the F. Okay, so instead of the letter Y, it's the letter F. Now the X is the sideways part. What was it? That was the temperature. So now what have we got? F equals some number, which I don't care about, times the temperature raised to what power? And if we had done the experiment perfectly well, the answer should be 4. So it should say F is equal to some number, temperature raised to the 4th power. That should be familiar. What formula is that? That's Stefan's law. And so what must have been that number that I said I didn't care anything about? That should have been Stefan's constant, the Stefan-Boltzmann constant. All right, so now that pretty much finishes up the lab so that you can answer all the questions in the lab. Make sure and answer them all. And then also answer the post-lab questions. And then email it to me. Okay? So there you go. If you got any questions, send me an email and I'll try to help you with the lab. But see if you can do it by yourself and then email it to me. Okay, so that's that lab for you, and then I will see you in class.